collide and stick together, they might snowball into icy planet-sized balls and escape the dead star to roam interstellar space forever. Beyond the Milky Way lies an unimaginable array of other galaxies, reaching to the ends of space itself. Although we have yet to see the most distant of these galaxies, the Hubble Space Telescope is revealing more than we've ever seen before. The most detailed images are of the 25 or so galaxies clustered near the Milky Way. This 3 million light-years wide cluster is called the Local Group. The galaxy closest to the Milky Way is the Large Magellanic Cloud. This dwarf galaxy orbits the Milky Way at a distance of 170,000 light-years. Looking into this galaxy, Hubble saw supernova SN 1987A standing out brightly against clouds of gas and stars. The stellar remnant left by the supernova is surrounded by inner and outer rings and a field of diffuse clouds of gas. The blue stars near the remnant are immense, more than 6 times the mass of the Sun, and about the same age as their supernova neighbor. The Large Magellanic Cloud holds young stars too. The nebula 30 Doradus is the largest star-forming complex anywhere in the Local Group of galaxies. The stars in cluster R136, the large blue spot, are unleashing ultraviolet radiation and high-speed material. This collapses the gas and dust surrounding them into pillars. Hubble's near-infrared camera penetrated the dust to uncover these stellar embryos. In 2 million years, the ones with enough dust to shield them will become an entire new generation of stars. A closer view of the cluster R136 reveals the cosmic forces at play there. The stars in this 2 million-year-old cluster are much hotter and more massive than the Sun. These images, taken in infrared and visible light, show the stars pouring out ultraviolet radiation and gas at thousands of miles per second. Where these collide with cold molecular hydrogen, new stars burst to life. Like their older kin, the fledglings are creating havoc, blowing the tops off their enshrouding dust columns and ejecting jets of matter into their surroundings to create moving, glowing patterns. South of 30 Doradus is nebula NGC 2080, a star-forming region called the Ghost Head Nebula. Radiation and winds from nearby stars fluoresce the nebula's gases. The blue and red light from hydrogen and the green from oxygen help astronomers analyze star formation. The white eyes of the ghost here are 2 blobs of hydrogen and oxygen in a bowl carved in the gas by stellar emissions. Elsewhere in the Large Magellanic Cloud, Hubble found a compact star-forming region in nebula NGC 1748. The star at the nebula's center is 30 times more massive and 200,000 times brighter than the Sun. Its intense radiation and powerful stellar winds have burnt and blown away gas and dust, creating a star-forming bubble 25 light-years in diameter, about the same size as the Orion Nebula. Near the edge of the Tarantula Nebula, in the Large Magellanic Cloud, lies an ancient star cluster, Hodge 301. So old is Hodge 301, nearly 10 times the age of neighboring cluster R136, that many of its stars have already gone supernova. They are blasting material at almost 200 miles per second into the rest of the nebula. This compresses the nebula's gas into a beautiful tapestry of glowing sheets and filaments. Nothing like the young double cluster NGC 1850 exists in our galaxy. A large globular cluster 50 million years old is paired with a smaller 4 million-year-old cluster. The smaller cluster contains hot blue stars and red T Tauri stars. The latter are solar-class stars, still forming and too young to convert hydrogen to helium like the Sun. Rather, they radiate energy released by their gravitational contraction. The 2 clusters are surrounded by a filigree of diffuse blue gas, probably created by massive exploding stars. Another nearby dwarf galaxy is the Small Magellanic Cloud, 200,000 light-years from Earth. There, Hubble found nebula N81. It holds 50 tightly packed stars within a 10 light-year wide section of its core. The closest two are only a third of a light-year apart. The dramatic shapes in the nebula's gas walls are being sculpted by the furious expulsion of mass from these superhot stars. Much more distant, about 40 million light-years from Earth, is the barred spiral galaxy NGC 1808. Deep in its center is another vast starburst region, this one between 50 and 100 million years old. This exceptional burst of star formation may come from a tidal interaction between this galaxy and another. The collision would have hurled gas into the galactic nucleus, igniting the starburst. It would also cause the warping of the galaxy's outer spiral arms and elongate the galaxy's nucleus. Looking beyond the Magellanic Clouds toward Andromeda, the next nearest galaxy to the Milky Way, Hubble captured this view of globular cluster G1, a brilliant ball of light consisting of 300,000 or more old stars. Also known as Mayall 2, the cluster is 130,000 light-years from the nucleus of Andromeda and is the brightest globular cluster in the local group. The local group of galaxies is only the beginning. In the first 100 million light-years beyond it, Hubble is finding galaxies filled with stars at nearly every stage of evolution. Deep within elliptical galaxy M32, 2.5 million light-years away, lies this swarm of 8,000 hot blue stars. This image recorded ultraviolet light using Hubble's Space Telescope imaging spectrograph. It demonstrates that ultraviolet light comes from extremely hot, helium-burning stars nearing death. Unlike the Sun, which converts hydrogen into helium, these old stars have exhausted their hydrogen and now turn helium into heavier elements. A starburst galaxy is one where stars are being born at an exceptionally rapid pace. Just 10 million light-years away, the large spiral galaxy NGC 253 fits the profile. Clumpy gas clouds, darkened dust lanes, and young luminous central star clusters. 4 superstar clusters here indicate a high rate of star formation and may help us understand the origin of our own galaxy. Within the core of 253, Hubble let astronomers quantify complex structures in the starburst area for the first time. In a region only 1,000 light-years across, we see luminous star clusters, dust lanes tracing regions of dense gas, and filaments of glowing gas. The multiple regions of star formation include one bright supercompact star cluster. Galaxy Centaurus A is rimmed by a dark belt of dust, blue clusters of newborn stars, dust filaments, and glowing orange gas. 10 million light-years away, Centaurus A is one of the closest galaxies to Earth to contain an active galactic nucleus, a huge black hole at its center. This black hole exhibits a phenomenon common in the early universe. It is feeding on a smaller galaxy. Hubble's near-infrared camera looked through the galaxy's dust wall to reveal this mystery for the first time. The black hole, though not much larger than our solar system, already contains a mass equivalent to about 200 million stars. 12 million light-years away, we find the small galaxy M82, which long ago moved closer to its larger neighbor M81. These infrared and visible light pictures depict the large star clusters that arose from the resulting gravitational interaction. Over 100 young bright star clusters in M82's center each contain about 100,000 stars. Astronomers have determined that this interaction began some 600 million years ago and lasted about 100 million years. Only a million light-years farther, visible in our southern skies, the Circinus galaxy, a Type II Seyfert, exhibits another active galactic nucleus. The black hole in Circinus is expelling gas out the galaxy's disk and into its halo, the spherical region surrounding the galaxy. The gas appears as magenta streamers extending up from the galactic disk. 2 rings within the galaxy hold gas, dust, and starburst areas, where new stars are quickly forming in a short 40 to 150 million years. Also 13 million light-years away, galaxy NGC 4214 is forming star clusters from interstellar